Hi, this is Ben McCone with Technically Speaking at Source Allies. Today we're going to be talking about, actually solving day 4 of Advent of Code 2025 live on air. So let's go ahead and jump right into it and start reading the problem. I like to stop in here and just start reading through the problem. Typically, when I am solving the problem for the first time, I skip much of the narrative and will look for the actual problem that we are trying to solve. I will say, make sure to go back and read the examples or read the story, because it is always great fun. Yesterday we got to read about the elves and their joltage, their fictional power metric. But today, we are helping the elves wrap gifts, I believe. So we have a grid. Grid problems are one of my favorite within Advent of Code. And in this grid, we are trying to see which are accessible by forklifts. So a piece of paper is only accessible by a forklift if there are fewer than 4 rolls of paper in the 8 adjacent positions. That means that this piece of paper here would be accessible because there are only 2 neighbors in the 8 surrounding spots. So let's go ahead and copy this input and keep rolling. It looks like in that example, there are 13 roles that are accessible, marked with the X's. And we see the one that I had called out was replaced with an X, meaning yes, it was accessible. Let's go ahead and switch over to VS Code. I have some test code set up, and we see we are looking for 13. And I will paste in our test input right here. This year, I am using a language called Crystal. It looks very much like Ruby, the main difference being that it is a compiled language and tends to run faster once compiled. So while we are in here, we will need a couple of things for us to really work effectively. One, whenever I create a struct, I like to create, or whenever I create a point in space, I like to deal with structs that give us the X and Y coordinates, along with a hash rather than a 2-dimensional array. We will talk a little bit more about this throughout struct point, and we will let Copilot complete that. This gives us 2 properties, X and Y, and then a constructor that automatically assigns those. So let's go ahead and create a map. So we have a map is a hash. I'm going to turn off Copilot here. Just turn it off, and we will go ahead and code this live. So in Crystal, we have to define our types. It is a strongly typed language. So we will have a hash point to a char. And we will initialize that new. We will say, you know what, let's go ahead and run this early and often, make sure that my syntax is correct, because I am still learning Crystal. So let's go ahead and split this input by line so that we get our rows. We'll map with index, and we'll say we have our line and we have our Y coordinate. And then we will do the same thing with our line. We will do a line.chars.map. We should probably do each with index. Each with index, we aren't actually mapping. We will be filling our map up above. Do, so ch for char and x for our x position on the map. And even though we have done no work, let's run this one more time, make sure that we compile and run successfully, and we do. So now we will say map, let's create our point equals point.new, x comma y, and then in our hash, we will say map of pt equals ch. And for good measure, let's puts our map. go ahead and run that one more time. And we will see a very large map, but we see at 0, 0, there's a dot. At 1, 0, there's a dot. At 2, 0, there is an at symbol. And if we look at that first line, that holds true. From there, now we need to, actually, it would be nice to have a neighbors function for our point. So let's create that really quick. Neighbors, this will return a list of point. And let's go ahead and just do point dot new self dot x minus 1 self dot y comma, and we'll do this 8 more times. 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8. Yep, we're good. So now we just need to do x minus 1, x plus 1. We'll do x minus 1, y minus 1. X minus 1, or x, let's continue the pattern, x plus 1, y minus 1. Let's see, x minus x plus, x minus x plus. So we have let's see, I need to pull up the map to the side. Let's go ahead and see. Looking at this guy, we have x minus 1 at the same level of y. We have x plus 1 at the same level of y, so we have this middle row taken care of. Then we have the up and to the left, up and to the right. We need the same position, x, 1 up, and then we need to do these 3 down here, but all of these x's and y's need to be pluses. Plus, plus. This is a minus, this is a plus, and then an x. All right, so really quick, let's see. We have to the left, we have to the right, we have up and to the left, we have up and to the right, we have up, just directly up, we have to the right and down, we have to the left and down, and we have straight down. That is all 8 directions. Perfect. We eventually got there. So now we simply need to say map. I believe we can do map.map actually, or dot count. Let's do this and see. Let's see what we can, if we can count. So what I'm expecting is we can count. Let's just print the point, and then let's count where ch is a at symbol. How many rolls are there? How many pieces of paper are there throughout the entire solution? That printed our map. So let's go ahead and do C for count. Let's delete that print, and let's print our C. Oh, I see. We had a 71. 71 at symbol, so yes, we can count. This gives us the ability to start looking at all of the other map neighbors within this counter function. So we're going to count the number of neighbors, or the number of points that have fewer than 4. What was the question? Fewer than 4 rolls of paper. All right, so fewer than 4 neighbors that are an at symbol. So let's go ahead and say neighbors equals pt.neighbors. And then let's say neighbors.count we'll go ahead and do an inline loop here for a pt 0.2, and then say pt2 equals, it's going to be map of 0.2 equals a dot, equals an @ symbol. And we want to say that is less than 4. And I think we're already going to have an error with this, but let's see. We have an error saying what? Still 71 is being printed out, which is not what I expected. Let's go ahead and reference, I'll bring this tab up, the enumerable class, and count does take a block, so that should be working. Let's go ahead and instead of map.count, do map.map. We are getting crazy here, and we're going to run this again, and we will see what we get. Neighbors is a list of point, undefined constant list. Oh, I have been doing too much Python lately, and that is an array, not a list, and you assign a generic with a parentheses. We will get there one day. All right, it looks like there is a key error. I feared that this would happen, but have no fear. This is another difference between Crystal and Ruby. In Ruby, if you index into a hash and that item does not exist, you simply get a nil value. In Crystal, you have accessed uninitialized memory, but we can simply say, add a question mark and say that we are okay receiving a nil value. And now we see true, 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 false, false, true. We see all of those filled in as we would expect. Let's change this to a count. We will go ahead and return C instead of printing it, because I think that we will pass. No. Okay, time to debug one more time. Why did we get 0? We were getting true in that array. Let's try that one more time. And another difference, Ruby has length, size, count. In Crystal, it is size. Let's go ahead and run this, and we see C is filled up the way that we want. C.filter, and we will just give ourselves the ampersand. We want to filter to an ampersand, and what this does is it gives you the identity of what is there, and we are only filtering to truthy values. Unterminated call, never mind, we can't do that. Do C or V for value. We want to filter only to truthy values, and then we will do .size on that. Let's go ahead and run it again. Filter is not there. Is it select? There are several differences between Crystal and Ruby, as we can see. And we got 19 instead of 13, so it looks like we have a bug. Let's go ahead and take a look. My guess is that there is a problem with neighbors. So I am going to create a point at 0, 0 and get neighbors and see, do I have a duplicate value? It would also probably help if I simply put these into a normal order. So let's go ahead and do that actually first. Top left, top center, top right, to our left, to our right, we don't count ourselves. Straight down, straight to the left, and straight to the right. So these are the neighbors that I would expect. Let's go ahead and let's read one more time. Let's actually just do a sum here, map.sum, our point and our character. We're getting our neighbors. We're looping over our neighbors. And let's see. I accidentally generated over. Thankfully, VS Code has an undo stack. That could have been tragic. Let's see. Undefined method 0 for bool class. I will be right back. It seems as though something is going on. I'd like to debug this off screen, and we will be right back. And we're back. So as we see, I have actually done a bit of debugging, and I'm not sure exactly what the root cause is, but I have found that while it's failing right now, if we simply only fill our map with the locations that the paper does exist, if ch equals paper, then we avoid the issue and we are able to get our answer of 1516. Let's go out here and enter that, and we got our first gold star. Let's go ahead and look at our part 2. Generally speaking, part 2s are more difficult, so let's hope that I didn't code myself into a corner. It looks like once a roll of paper can be accessed by forklifts, it can be removed. Once that roll is removed, we can access more rolls, so it looks like we need to do this recursively. We remove 13, and at a certain point, there will be no more that are accessible, and a total of 43 rolls were able to be removed. So let's go ahead, go into our test. I have a special, I skipped the second test originally. It uses the same input, I believe. Yes. We will fill in our test with 43. And this has been going so well, let's actually copy our part 1 solution down to part 2 and get started on it. Let's run this test. We will obviously fail. And let's actually take a different approach, and let's say sum equals 0, I32. This is simply an integer. By default will be a 32-bit integer, but I do like to be explicit. And instead of doing a c equals map.count, let's go ahead and return sum. And we'll say sum plus equals I32. That is not right. We will say sum gets added on to map.count. So let's go ahead and give that a go. We still get 13 as expected, but now we are collecting that into sum because we need to go over the map multiple times. Now, what I'm thinking here is we can actually just adjust this loop and put a while loop around it in an interesting way. Let's go ahead and bring our count in here, and this is going to be count is that. Now we have access to our count variable, and we can say count is less than 4. Same behavior will arise. We will have an answer of 13 when we expect 43. But what this gives us is the ability to say if count is less than 4, we can say map of pt equals nil. And now it should still work the same. I may need to adjust. That is not a character. Can I say or nil there? Does that work? No. One more shot before I go to Google. Maybe it is like TypeScript. Okay, that got us to 30. We will see if this is the correct approach. So let's say old sum equals sum. And we will say while old sum does not equal sum. Now, I do recognize that this will not work immediately, but let's go ahead and actually just say old sum equals 1. That's fine because we can say old sum. I have this backwards, don't I? Let's actually say while true, and let's say value for this iteration, and then say if break if val equals 0, sum plus equals val. And let's go ahead and run that again. What I am attempting to do here is update the map in a greedy fashion using a greedy algorithm. And we will go ahead. I see that I have a plus equals before the definition of val. That makes sense because we are no longer adding, we are initializing a new value. But we can see, with any luck, this will work. Hopefully the input is not too large that this is, this takes too long. We may have to go back to the drawing board. Let's go ahead. Let's go ahead and kill this terminal, start a new one, and bring that up here. Let's go ahead, go over to our spec, and let's just say break if, let's just add a loops so we don't have to kill the terminal. Loops equals 0. Break if loops is greater than 100. Loops plus equals 1. And let's go ahead one more time and see what we get. All right, it is obviously not working. We are getting a much larger number than we need. So let's go ahead and see if count is less than 4, map of point is nil. I expected that to work because we are working. Let's actually, can I delete? Map.delete pt. Okay, so again, it looks like my understanding of hash objects in Crystal is flawed. I will need to research that off camera, but we got our second star by actually deleting the value rather than setting it to nil. This has been Ben McCone with Technically Speaking at Source Allies. Do you have a topic you'd like to see covered? Comment down below. Check out sourceallies.com to learn more about us. Thank you. And as an extra ask, if you have been completing Advent of Code or you have a favorite language that you like to use, comment down below. I'd love to hear a little bit more about how your Advent of Code is going, what you're doing, what has been exciting you. I hope you enjoyed today's video, learned a little bit about Crystal with me, and we'll see you next time. Thank you and goodbye.